Welcome to our microlearning channel. The universe is held together by fundamental forces that govern the interactions between all matter, from the smallest particles to the largest galaxies. These forces are the invisible threads that weave the fabric of the universe, allowing it to function and evolve. Understanding these fundamental forces is crucial to our comprehension of the cosmos and the physical laws that underpin it. In this presentation, we will explore the nature of these forces and how they shape the universe we live in. Forces are invisible influences that act on objects. They are pushes or pulls that can cause changes in motion. Forces occur when objects interact with each other. Forces are fundamental to understanding how the physical world works. Understanding forces is key to explaining phenomena like gravity, friction, and momentum. The four fundamental forces that govern the universe are gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Gravity is the force that attracts objects with mass, like planets and stars, towards each other. Electromagnetism governs the behavior of charged particles, like electrons and protons, and is responsible for phenomena like electricity and magnetism. The strong nuclear force is what binds protons and neutrons together in the nucleus of an atom, overcoming the repulsive electromagnetic force. The weak nuclear force is involved in radioactive decay processes, where certain unstable atomic nuclei spontaneously transform into more stable configurations. These four fundamental forces shape the structure and evolution of the universe, from the largest galaxies to the smallest subatomic particles. The image on this slide depicts a small cartoon apple falling towards a large, cartoon Earth, with a playful, soft lighting. Gravitational force is the fundamental force that attracts objects with mass towards each other. This force depends on the masses of the objects involved. The more mass, the stronger the gravitational pull. Importantly, gravitational force acts over any distance, with no limit to its range. Even objects very far apart exert a gravitational pull on each other. The key points to emphasize are that gravitational force attracts objects with mass, the strength depends on the masses involved, and it acts over any distance without limit. The electromagnetic force is one of the four fundamental forces in nature, along with gravity, the strong nuclear force, and the weak nuclear force. Magnetic fields surround magnets and moving electric charges. They can exert forces on other magnetic materials and moving charges. Electric charges come in two types, positive and negative. Opposite charges attract, while like charges repel. Electromagnetic radiation, including light, radio waves, and X-rays, is a form of energy that travels as waves through the electromagnetic field. All of these electromagnetic phenomena are governed by the same underlying principles and laws. The strong nuclear force is the fundamental force that holds the nucleus of an atom together. This force overcomes the electrostatic repulsion between the positively charged protons in the nucleus, keeping the nucleus intact. The strong nuclear force is a short-range force, meaning it only acts within the very small confines of the atomic nucleus. This force is incredibly powerful, over 100 times stronger than the electromagnetic force, allowing it to bind the nucleus together despite the repulsive forces between protons. The weak nuclear force is one of the four fundamental forces in nature, responsible for radioactive decay and certain neutrino interactions. Radioactive decay transforms unstable nuclei, changing the composition of the atom. This is a key process driven by the weak force. The weak force involves the exchange of W bosons, which mediate interactions between particles like neutrinos. Unlike the strong nuclear force, the weak force has a very short range, acting only within the nucleus of an atom. The weak force plays a crucial role in many nuclear processes, despite its limited range compared to the other fundamental forces. Newton's three laws of motion provide a foundation for understanding how objects move and interact. The first law states that an object at rest will stay at rest, and an object in motion will stay in motion, unless acted upon by an external force. The second law tells us that the force acting on an object is equal to its mass times its acceleration. This explains how objects accelerate under the influence of a force. The third law states that for every action, there is an equal and opposite reaction. This means that when one object exerts a force on another, the second object exerts an equal and opposite force back on the first. These three principles form the basis for much of classical mechanics and help us understand a wide range of physical phenomena. Walking is a simple example of applying force. We push against the ground to propel ourselves forward. When driving a car, the engine force propels the vehicle, overcoming forces like friction and air resistance. Lifting objects requires applying an upward force to overcome gravity's downward pull. This allows us to move things vertically. Throwing an object involves applying a force that changes its motion, imparting kinetic energy and causing it to move through the air. These examples illustrate how forces play a crucial role in our everyday interactions with the physical world around us. Balance forces are equal and opposite forces acting on an object. When forces are balanced, there is no change in the object's motion. It remains at rest or continues moving at a constant speed. Unbalanced forces, on the other hand, are forces that are not equal and opposite. Unbalanced forces result in acceleration. The object will speed up, slow down, or change direction. It's important to understand the difference between balanced and unbalanced forces to predict how objects will move. Work is the application of force over a distance. Energy is the capacity to do work. It comes in different forms like kinetic, potential, thermal, etc. Power is the rate at which work is done. It measures how quickly energy is transformed or transferred. Understanding the relationships between work, energy, and power is key to analyzing many physical systems and processes. The main topic of this slide is the fundamental conservation laws in physics, conservation of momentum and energy, and how forces relate to these laws. The first point is about conservation of momentum, that the total momentum of a closed system remains constant, even as individual objects within the system may change their momentum. The second point is about conservation of energy, that energy cannot be created or destroyed, but can only be transformed from one form to another. The third point is about how forces are the mechanism by which energy and momentum are transferred between objects in a system. The visual on the slide is a dynamic illustration of two colliding billiard balls, showing the transfer of momentum and energy through the forces acting between them. I'll use this slide to introduce these core physics principles and set the stage for diving deeper into the details of how they work. The image on this slide represents the quest to unify the fundamental forces of nature, the grand challenge of theoretical physics. This timeline highlights some of the key areas of force research that will shape the future of our understanding of the universe. Unification theories aim to find a single mathematical framework that can explain all the forces we observe, from electromagnetism to gravity. Quantum gravity is about understanding how gravity operates at the smallest scales of the quantum world. Dark matter and dark energy are two of the biggest mysteries in physics today. We still don't know the nature of these unseen forces that make up most of our universe. New particles and interactions could lead to the discovery of entirely new fundamental forces, expanding our model of reality. This slide sets the stage for the exciting frontiers of force research that will be explored in more depth in the presentation.